Hi everybody, I'm Eugenio Tacchini. I'm the founder of Databic. I teach databases and information systems at university, and I'll introduce you to the world of SQL. Most of the videos on this channel are related to Databic. This is currently the only video related to a more general topic, SQL. It's a basic tutorial. I try to teach you the very basics of SQL in about 30 minutes. But what is Databic and how it is related to SQL? Databic is a low-code development platform, a piece of software you can use to build database applications without any coding or using just some code. Databic doesn't need SQL to be used, but if you know some SQL, you can customize even more your applications. So the target audience for this video is a Databic user or anyone who needs SQL. For example, a software developer, a student that needs to learn SQL, a data scientist. Well, if you are a data scientist, probably you already know some SQL. Let's say I want to be data scientist. Anyone who needs to learn SQL, anyone who works with data and needs to extract information from a database. So, first of all, what is SQL? SQL stands for Structured Query Language. It's the language we use to communicate with our database, or to be more precise, with our database management system, DBMS. I don't want to stress too much this difference right now. I just want to tell you that a database is any organized collection of data, for example, a list of customers with their phone numbers, while a DBMS is the software we use to manage such collection. For example, MySQL or Microsoft SQL Server are two examples of DBMS. I'm using MySQL as DBMS in this tutorial, and MySQL Workbench as a tool to execute our SQL queries. It's a tool you can freely download from the MySQL website. You'll find a link in the description of this video. I will use some simplifications to make everything easy, but what you learn here is something that you can really use in real-world situations. For the rest of the tutorial, we'll move to MySQL Workbench because we are going to learn by examples and it's easier for you to follow, okay? Let's see, first of all, how information is typically stored in a relational database. Information is stored in tables. We should say in relations, but let's keep it simple for this introduction. So, for example, this is a table containing the information about our customers. A row in the relational model jargon is called a record. And these are the attributes or the columns or the fields of the table, okay? Pay attention to the column ID customer. It's important because it's an attribute that uniquely identifies each customer in our table. We cannot have two customers with the same ID. We call it primary key. There is more to say about primary keys, but again, for the moment, let's keep it very simple. In this tutorial, we are going to see four basic SQL operations: select, insert, update, and delete. So let's start with select, and let's say we want to get first and last name of all our German customers. Here is the SQL query I have to execute. Select first name customer, last name customer from customers where country customer equals Germany. Let's see the result. We get two records, a subset of all the records. Here we can already see the basic parts of a select query. Select from where. In the first part, the select part, we choose the columns we want in our results grid, in our report. In our case, it was first name and last name. We have to use a column as a separator, as you can see. In the second part, the from part, we specify the table where the data is stored. It was the customers table. And finally, in the where part, the rows we want to select. So basically, with the where clause, we set a filter. Here we say, I don't want to retrieve all the rows, I just want some of them. I only want to see customers coming from Germany, right? The where part is optional. If I don't specify a where clause, I get all the records. A quick note on the first part, if you need all the columns, you can, instead of specifying all the column names, use an asterisk. One thing I want to clarify is about lower and uppercase letters. If you look at this query, why select from where are uppercase? Because they are SQL keywords. Actually, you don't have to write them uppercase. It works even lowercase. But by convention, people often write SQL keywords uppercase to distinguish them from the rest of the query. And I am following the convention in this tutorial. How about the word Germany? Can I write Germany in capital letters? Will I get the same results? Yes, in this case, yes. And in most of the cases you will deal with in real-world problems, string comparisons will be case insensitive, because normally for MySQL this is the default configuration. You can configure a field to do case-sensitive comparison if you want, but this is not the topic of this tutorial. Another optional part is the order by part. When you select records, they are not sorted. If you want to sort by a particular field, you can just add something like order by last name customer. As you can see, now the customers are sorted by last name. You can also get descending order by adding the DESC keyword. Alright, so in this case, first we have a Smith, then a Schulz, and so on and so forth. About the filter, the where part, it can be much more complicated than the one I showed you. Of course, I cannot show you everything in this tutorial, but I'll give you some useful hints to start. First of all, equals is not the only operator we can use. We have other operators such as greater than, less than, and not equals. So for example, if I want to show all the customers older than 25, where age customer greater than 25. Another very useful operator is the like operator that you normally use to match a string pattern. For example, if I want to get the name of the customers having a first name that starts with MA, first name customer, like between quotes, MA %. which means the first two characters are M and A. Then anything is fine. Percent is a so-called wild card. So you can have 0 or more characters after MA, any character. So we got Marco and Marti. Let's now get the name of the customers who live in a city having a name ending in MA. City customer, like between quotes, percent MA. So 0 or more characters at the beginning, but the string must end with MA. We got Silvia because she lives in Roma. Finally, let's say we want to get the name of the customers having a first name that contains the letter A. So the letter A can be at the beginning, in the middle, at the end, anywhere. Like between quotes, percent, A, percent, which means 0 or more characters at the beginning, letter A, 0 or more characters at the end. You can do other things with the like operator, but these ones are probably the ones you are going to use quite often. You can also connect different criteria. For example, let's take the German customers, but not all the German customers, only the customers older than 25. So in this case, where age customer greater than 25 and country customer equals Germany. Note that Germany is a string, so it's between quotes, while 25 is a number. Age customer is a numeric field, so you don't have to use quotes. But this is not super important right now. Let's focus on the AND Boolean operator. AND means that both the conditions must be true in order to select the customer. So let's see another example using another Boolean operator, the OR Boolean operator. Select asterisk from customers where country customer equals Germany or country customer equals Italy. Here, even if just one condition is true, the customer is selected. So I get both customers from Germany and customers from Italy. Question: what happens if I write the statement as country customer equals Germany and country customer equals Italy? Of course, I get no customers, simply because it's impossible for both the conditions to be true. A customer cannot have Germany as country and at the same time Italy as country, right? I can also create complex filters combining several conditions using AND or parentheses, but I won't go into these details right now. Until here, very easy, right? I hope so. Things are more complicated if your data is spread among several tables. Here is a typical example. Let's say we have two tables, sales and customers. In the table sales, we store each sale we did. So each record represents a sale. Each sale has an ID, a date, the product sold, and we assume, to simplify, that for each sale we can only have one product, the price, and the ID customer. So here we store, using his or her ID, the customer who made the purchase. So, for example, Marco Rossi, having ID 1, is the customer who made this purchase. That's the typical way used by the relational model to link two tables. We use the primary key of a table as a foreign key in another table. Okay, let me ask a question. Let's say that for each sale made after January the 2nd, 2019, I want to show the date, the product, and the ID of the customer. It should be easy, right? So select date sale, product sale, ID customer from sales where date sale greater than 2019, the year, dash 01, the month, dash 02, the day. But what if instead of the ID of the customer, I want to show the name of the customer? We cannot get it. I mean, if I try to write first name instead of first name customer instead of ID customer, I get an error. So why? Because first name customer is not a field belonging to this table, the sales table. It's a field belonging to another table, the customer table. So what we need to do is to join together the two tables using an SQL operator called inner join. Basically, you should imagine to take each record of the first table and to join it with the correspondent record of the second table, like this. Think about a super table that is the result of the sales table plus the customer table. Can you see what we did? Each record of the sales table is now connected with the record of the customers table having the same ID customer. How do you translate this in SQL? You add the second table, customers, in your query. So from sales, inner join customers. But this is not enough. You have to tell the DBMS how to link together the tables. We specify the rule to use like this. Sales.idCustomer equals customers.idCustomer, which means the ID customer in sales and the ID customer in customers must have the same value. Okay? It makes sense. You don't want to link this record with a random record of the table customers. You want to link it with the record having exactly the same ID customer. Let's try it. So, same number of records, of course, same sales, but instead of the ID of the customer, we now have the name. The inner join is not the only type of join we have. We also have the outer join. Left outer join, right outer join, full outer join, but for this tutorial I think you should just focus on inner join, which is the one you are going to use the most. Okay, until now we have analyzed operations that allow us to retrieve data from our database. Let's see now the operations that allow us to modify the data in our database. When do you need to modify the data? In many cases, for example, every time you sell something in your e-commerce website, probably a new record is registered, is inserted in the table sales. How can you perform this insertion in SQL? You need an insert statement. So insert is used to, surprise, surprise, insert records into a table. And this is the syntax. Insert into table name, field 1, field 2, and so on and so forth, values, value 1, value 2, and so on and so forth. So first we specify the field names and then the actual values we want to insert in each field. So let's register, for example, a new sale using the simple sales table I've used before. Insert into sales, date sale, product sale, price sale, ID customer, values, 2019, January the 5th, laptop whatever, 500 the price to the ID customer. You might notice a couple of things here. Again, for 702, because we are talking about numeric fields, we don't use quotes, while for strings and dates, we use quotes. Yeah, I mean, to be more precise, this is a string representing a date, but again, it's not very important now. The second and more important thing is I didn't mention ID sale in my query. Why? So basically I mentioned all the fields except from ID sale. Because in this table I declared ID sale as an auto-increment field. Basically, when we insert a new record in this table, the value of ID sale is automatically assigned by the system. The first sale is 1, then 2, then 3, and so on and so forth. So you don't necessarily need to specify all the fields in an insert statement. If a field is auto-increment, you don't need. If a field has a default value, you also don't need. Also, if a field allows the null value, you can omit the field. And if the field doesn't have a different default value, the value for that field will be null in that case. But what is null? There is often some confusion about this value. I won't go too much into details here. The only thing you need to know is that we have a special value, it's called the null value, to represent the non-existence of the value or the fact that the value is unknown. For example, let's say you have for your user's registration form the field phone number, but let's assume the phone is not required. A user can register even without giving you the phone. If the user doesn't provide the phone number, the most correct thing to do is to register a null value for the phone number. If you want to explicitly assign a null value during an insert, you just write null, N-U-L-L, without quotes. Okay? So for example, let's assume we have an additional field, date delivered sale. The date order is delivered, okay? When the order is registered, you still don't have a delivered date, right? So you would do something like this. As you can see, I specified null for the field date delivered sale. You should consider, however, that not all the fields admit the null value. When you create a table, which is a process we don't see in this tutorial, the database design process, you define if the field admits or not the null value. And remember that a primary key field never allows the null value. Okay, update. Update, of course, is used to modify one or more existing records. Here is an example. Update customers, set city customer equals Venezia, where ID customer equals 1. The where clause works like in the select statement. We filter the records we want to modify. In this case, I want to modify only one record, so I'm using the primary key of customer, ID customer, in the where clause to be sure I'm taking just that record. Remember that I cannot have two customers having the same ID. Never forget this. Let's see the result. The first customer now lives in Venezia. And now let's generalize a little bit more the syntax. That is update table name, set field1 equals something, comma, field 2 equals something, and so on and so forth, where filter. So we specify the table name, we can specify one or more fields to update, and then we have an optional where filter. So in the previous example, if we want to modify both the city and the country, update customers, set city customer equals Tokyo, country customer equals Japan, where ID customer equals 1. In the previous cases, I modified one record, but I can modify several records at the same time, using the correct filter. Let's imagine for a moment that all our customers from USA moved to San Francisco. Okay? Update customers set city customer equals San Francisco, where country customer equals USA. So in this case, 3 records have been modified. Why did I say the where clause is optional? Because you can also omit the where clause. In that case, you will update all the records. Alright? Finally, delete. The syntax is very simple. Delete from table name, where, and your optional where clause. So we are deleting records from a table. For example, let's say you want to delete the sale having ID 1, delete from sales where ID sale equals 1, of course. And you are going to delete just one sale. But as we have seen for the update statement, I can delete more than one record with a single delete statement. Let's say I want to delete all the sales made by the customer 4. Delete from sales where ID customer equals 4. Again, the where clause is optional, but pay attention to that, because if you don't specify a where clause, you are going to delete all the records from your table, and that could be a disaster. Okay, that's it for this introduction to SQL. If you have any question, you can post a comment, and see you next time. Ciao!